The figure above shows the graph of the function f defined by fx is equal to mod 2x plus 4 for all numbers x. For which of the following function g defined for all numbers x does the graph of g intersects the graph of f? A. Gx is equal to x minus 2, B. Gx is equal to x plus 3, C. Gx is equal to 2x minus 2, D. Gx is equal to 2x plus 3, E. Gx is equal to 3x minus 2. Explanation. You can see that all 5 choices are linear functions whose graphs are lines with various slopes and y-intercepts. The graph of choice A is a line with slope 1 and y-intercept minus 2 shown in figure 6. If we observe figure 6, we realize fx has twice the slope of gx and the two lines diverge from each other and they never intersect. It is clear that this line will not intersect the graph of f to the left of the y-axis. To the right of the y-axis, the graph of f is a line with slope 2 which is greater than slope 1. Consequently, as the value of x increases, the value of y increases faster for f than for g, and therefore the graphs do not intersect to the right of the y-axis. Choice B is similarly ruled out. Note that if the y-intercept of either of the lines in choice A and B were greater than or equal to 4 instead of less than 4, they would intersect the graph of f. Choices C and D are lines with slope 2 and y-intercept less than 4. Hence, they are parallel to the graph of f to the right of the y-axis and therefore will not intersect it. Any line with the slope greater than 2 and y-intercept less than 4, like the line in choice E, will intersect the graph of f to the right of the y-axis. The correct answer is choice E, gx is equal to 3x minus 2. If we take x is equal to minus 3, then f of x is equal to mod 2x plus 4. 2 times minus 3 is equal to minus 6. If we take the mod of that, we get 6. 6 plus 4 is equal to 10. Similarly, for different values of x, we can calculate the f of x. The graph of the f of x looks like this. It is not possible for linear function given in multiple choice by g of x that it intersects f of x for the negative values of x. However, g of x can intersect with f of x for positive values of x. Option A, g of x is equal to x minus 2. If we calculate the value of g of x for different values of x, we get a graph like this. It will diverge from the graph of f of x and will not intersect it at any place. The function g of x is equal to x minus 2 tells us that the slope is 1 and the y-intercept is minus 2. Option B, g of x is equal to x plus 3. We know that the slope is 1 and y-intercept is 3. The function f of x and g of x will diverge from each other since f of x has twice the slope and has the y-intercept of 4. Option C, g of x is equal to 2x minus 2. We know that the slope is 2 and the y-intercept is minus 2. The function f of x and the function of g of x are parallel to one another for positive values of x. Option D, g of x is equal to 2x plus 3. The slope is equal to 2. The y-intercept is equal to 3. The function f of x also has a slope of 2 for positive x values and have the y-intercept of 4. Therefore, f of x and g of x are parallel to one another for positive x values. Option E, g of x is equal to 3x minus 2. The slope is 3 and the y-intercept is minus 2. For positive x values, the function f of x and g of x will converge and intersect at some point. Hence, option E is the right answer.